I have a question for Professor Carpentieri, who spoke first this morning. Is he still here?
Professor Carpentieri?
Maybe I could pose the question anyway, someone else could answer.
Professor Carpentieri, please come here.
My question, Professor, is that many of the reactions you illustrated this morning in your talk are in fact very endothermic. And if they were responsible in some way of causing 4% of the iron or 2%, or some measurable percentage of the iron to be transformed into aluminium and other lighter elements, where would the energy come from to do this?
Really, from the energetic point of view, we think that it is not endoenergetic, but isoenergetic. We have not, of course, we have not theories of models saying that, but from the experimental point of view, it's not endoenergetic. We are sure about that. I cannot tell you exactly why it can happen, but it is in this way. And I think it's related to interpretation of very well-known concepts. For example, the average binding energy per nucleon, no, is average. We know, for example, no, I don't say that it's the reason, but is average binding energy is not. We are not sure in other terms that energy, binding energy, is uniformly distributed in the nucleus. No? This is classical. It's not. It's classical. For example, maybe other reasons. When we say the defect of mass transformed in binding energy, not in free energy, and the binding energy can transform again in mass. Maybe this is a very well-known Einstein transformation energy, mass energy. So it's just an interpretation. My point is that we have to reinterpret very well-known concepts. We have not to reconstruct anything. I cannot tell you more than this.
If I may answer that, I don't think we need to rely on statistics to know what the masses of certain isotopes are. They can be measured.
Of course.
And we know that, for example, carbon, sodium, aluminium are lighter than, are heavier added together, or than the original products, the original reactants, which would be iron. So I don't understand where this mass difference could be explained. Yes. We can't rely on statistics to explain why.
No, you are right. I agree with you that we have to explain all this in the framework of condensed matter physics, and not only considering isolated nuclei. This is the same thing you are saying. Okay. So statistics, thermodynamics in general, and we have to think that all these very well-known relationships are average values. So about the peaks, we can have, for example, it's very simple hypothesis, I know, but if you consider average energy, you could have a peak of energy, binding energy, but also weak binding energies. So in that case, you can have a splitting of this nucleus for this reason. For example, it's not a theory, it's just a doubt, it's just a perplexity, just to revise all the theories that, of course, cannot explain what the news is on the table, no? What we have in the laboratory. So we have to be more, I think, more Galilean and less dogmatic in this field. This is my point.
Okay. Thank you.
Thank you, Professor. Any other question?
Andrea Aparo. I do work for Ansaldo Energia and also a university professor in Rome. Used to be a physicist when I was young and smart. I am neither nor, as you can see. There's an interesting phenomenon going on here this morning. Whenever you have a gathering of scientists, they talk about science. As soon as they go back home, they start to talk about business. It's never the case that when they're gathered together, they also talk or suggest possible roadmaps to accelerate the transition from labs to the real world. So I'm wondering why that happens. Mr. Chiantelli mentioned that today a risk is that there is too much media attention, that the business world is too much eager to jump on whatever new discovery in order to make money out of it. Where and what is the scientific community doing? Why can't you come up with some ideas of how to suggest a new research model? We don't have the time to do what we did in the past. We don't have the money to do that. Haven't you any good ideas to suggest? I mean, new models? Have we to set up a sort of CERN for low energy physics? Or shall we ask for help to the European community? Or what else? And it has to come from the scientific community, the idea for the project, not from the business world, or it would be biased. So I really recommend you to do a little bit of work on that. Thank you.
What is the question?
The question is, how do you want to go down the road? Where's the roadmap? I can't accept that you tell me for the next 20 years. I mean, it's like nuclear fusion, remember? When I started working in physics, it was going to be ready in 10 years. Now I'm always going to take my retirement, and it's still going to be in 10 years. We have to, but the Manhattan Project was done in quite a bunch of months, right? So the question is, are you thinking to come up with some suggestion on how to move fast from research to application? Thank you.
If you agree, I ask to Professor Carpentieri and Professor Agastijn to give two possible answers to this question. Please, Professor Carpentieri.
If I well understand, the question is which is the roadmap for the future? Of course, it's an important question, but I can say that in the last 4 years, we didn't have specific funding for this research. So it was based on personal sacrifices or in some way some other funds that were used for this research, for splitting these specimens and so on. So of course, in the future, we hope in the attention of the authorities, of the political people and so on. So of course, it's a good question, but I'm afraid that today we cannot answer. It's just maybe that this meeting could stimulate answers. So thank you for the question, but I've not really answered today.
But Professor, I ask this question to you as head of INRIM, so that
yes.
you are in chief.
No, of course, if I can speak about INRIM, where I have the responsibility to be the president, I think that in INRIM this is a topic of interest. It's not the only one, of course. We have hundreds of different, very important topics already studied for many years. So this is only the last one. But I would like to deepen through INRIM in the future. We already began, no? Somebody is interested in this topic freely. Nobody asked people to collaborate, but they were interested by the topic. And in this sense, I can say that INRIM is interested, but I can say that even maybe other public research institutions in Italy are today interested. Maybe not officially, not at the level of presidency and the multi-annual programs, I can say triennial or decennial program, but I think that I've shown at the beginning of my presentation a list of institutions where there are active researchers very interested in the topics. They are connected with my group, but in some way they have also independent results, from liquids, from solids, and so it's a very important topic, I think, for the future. This is my answer, of course.
Thank you. Professor
I
Agassi.
was speaking only about the government. I understood the roadmap for the government. So the government at the moment is not, at the government level, we have not the right attention, I think. But maybe in the future, yes.
Professor Agassi.
So in responding to the challenge here, I note that there's at least two different parts to the problem that need to be addressed. One is the technical part, what calculations need to be done, what experiments need to be done. I have many times made up a wish list, a Christmas list of experiments that would be nice to have in the field. For example, helium is correlated with energy production in the palladium deuteride experiment. However, but there's a problem in doing the measurements because the helium doesn't all come out during the experiment. So now that we have some understanding of this, what we would like to do is to do some new experiments to have high accuracy correlation of energy and helium-4. So that's close to number one on my wish list, and a very close number two is a correlation of helium-3 in connection with the nickel hydride experiments, because one suggestion is that HD reactions making helium-3 is providing the energy for such reactions. In connection with my model, the exchange of energy between vibrational systems and nuclear systems, the models are very clear about that kind of effect has to underlie these experiments within the approach that I've taken. There's an experimental result recently that I mentioned from Karabut where a coin is vibrated, a sample is vibrated, and collimated X-rays come out. Recently we have an idea of why that happens and how that happens, and one thing we would like to do is to get a controlled version of that experiment done in order to test it. There are many other things, experiments on my wish list. One is to do a replication of the Piantelli experiment, which I consider to be one of the most important experiments that's out there in the field. And there are many other things on the list. The other issue is how to get support for such work. In the United States, at the moment, outside of a program under Dennis Bushnell at NASA, there is no, currently as far as I'm aware, there's no other government support for any work in this area for such experiments. I recently had the experience of working with a large company in the US who was interested in pursuing experiments in this area and helping out. So we discussed with the technical people at this company the possibility that they might put in some money for the support of a replication of the Piantelli experiment. So they got agreement, they got the money, they got it to MIT, and we thought, good, now we can make some progress. However, a very famous physicist at MIT who is involved in the energy program found out what we were trying to do, and he canceled the program, and he called up the vice president of the company and said some things that weren't very polite about the research. And not only did the funding not come, the experiments didn't happen, but my colleagues at the company were very worried about where they were going to work next. As you know, there's unemployment issues currently in our bad economies. So there's fundamental difficulty with respect to getting support for the experiments. And what that means is that the science can be expected to go very slowly for these reasons until a solution is found for this problem.
Thank you, Professor. So that, thank you for all the speakers.
Meters from it is on the right, going out from this room.